Alright, hello everybody and welcome to the first lesson of this amazing chapter in which we are going to find out what arrays are, or we are going at least to recap them together because probably most of you have used arrays before, and we are going to go in depth and see what really happens behind the scenes when we are using arrays, what are the advantages and disadvantages of this data structure, and then we are going to see that there are actually two types of arrays, the static ones and the dynamic ones. Both of them will be used a lot, but in this lesson we are going to find out about the static ones. So let's start with a definition. An array is a data structure consisting of a collection of elements, values or variables, each identified by at least one array index or key. Most of you have probably used arrays before, so you are familiar with this kind of syntax. What happens in this piece of code is that we are declaring an array which will be named nums, which consists of integers and has a size of 10. So there are a lot of things that need to be discussed here, and the first one is this int. Static arrays can hold only one data type, so all the elements in our array should be of the same data type, right? There are programming languages like Python in which you can have a list that has integers, doubles, and maybe other lists inside it, but that list is actually a dynamic array, and we will talk about that in the next lesson. But yeah, in static arrays, only one data type. Then this is the name of the array, pretty straightforward, and this is the size. This is very important, right? Because when you declare a static array, you need to tell the computer what's going to be the size of that array. So you need to decide when writing the algorithm what's going to be the size, and then you can't change your mind. You can't during the program figure out that, you know what, I actually need more elements. I need 20 of them, so let's just add 10 more elements to this array. No, it doesn't work like that. Let's remember first what happens when we declare a variable. Let's say we want to use a variable which is an integer, for example. It's called x, and we can initialize it with 3. When we write this line of code, an integer is 4 bytes. So 4 bytes. So what a computer does is that it searches the memory for a zone of 4 bytes. Once it found it, it's going to say that, okay, this zone is reserved specifically for the variable x, so only this variable x is going to access it. In this memory zone, I am going to write the value of that variable, which is initially 3. Of course, it can be modified at any time, and x is going to actually point to that memory zone so that when we want to access or modify the value of this variable x, it goes there and overwrites the variable there, or just returns what's the number. Cool. Now, this happens for a variable. The array was designed because usually one variable is not enough. We are going to need maybe 2, 3, 10, 100 of them, which are of the same data type and are related to each other. So for example, let's say you want to store the prices of, I don't know, your server somewhere, right? And you have 100 servers and you need to know the price of each server. You're not going to do something like, you know what? Price 0 is going to be the price of the first server, price 1, price 2, and literally have 100 variables for each price. That is definitely not a good way to do this, and is definitely not feasible, right? So here arrays come into play, and we will say that, you know what, I actually need an array. Let's call it nums for this example, which will store the 10 integers, let's say, that I need, and that will be accessed throughout my algorithm. When we declared one variable, the computer found 4 bytes of memory and just reserved it for the variable. Now, when we declare an array, guess what the computer is going to do? It looks at its size, it looks at this data type, and will say, okay, so I'm gonna need a contiguous zone of memory, which is 4 times 10, 40 bytes. I'm gonna reserve it. And I know that I should equally split this zone into 10 pieces, and each subzone here is going to be a value from the array. This is not an easy task for the computer, and this is the exact reason why you can't change the size of an array from the start. You need to be careful that the size of the array that you declare is indeed the right one, and you're not going to need extra elements throughout the algorithm. Because if you need them, just think about this. This contiguous segment of memory in the whole computer memory, let's say, is this one, right? So this array is this zone of memory, right? Maybe the computer has already allocated these chunks of memory for some variables, right? Maybe this zone of memory is for the nums array. Maybe we have the variable x, and let's say the zone of memory allocated for this is this one. Maybe another variable y, and the zone of memory is this one. Maybe a variable z, and the zone of memory is this one, right? So once the computer manages the memory problem and makes sure that everyone has the memory that it needs, then it can't undo this. Awesome. Now, one other thing that you need to know is that when you declare an array, if you don't initialize its values, then these values can actually be random, right? Because think about it, the computer is going to find that memory zone that the array needs, but it doesn't care about what are the values there. Maybe, I don't know, there are some memory zones which were used 1 week before by some variable x and they haven't been cleaned up, and the value there is actually going to be the value of nums of 0 now. So if you want some specific values in this array, you need to make sure that you either initialize the array at first, maybe you initialize it with 10 zeros, right? So 0, 0, 0 everywhere. Or at least if you don't initialize them, make sure that before trying to access a value that you need, you have set it somewhere with what was that value, right? Awesome. The next thing that I want to talk about here is what are the operations that we can perform on an array. The first one is, of course, access some value, access some element, right? And as I said in the definition, each element is identified by at least one array index. The indices, or keys, but most of the people call them indices, are these ones. 0, 1, 2, ... the size of the array minus 1, right? So in this example, the array has a size of 10. So of course, because the array is 0 indexed, which is what most of the programming languages do, and what we will also do, because it's a very good practice, and not doing this, trust me, is going to be a red flag for the interviewer, is, yeah, they are 0 indexed. And as I said, the elements can be identified by the index, and the syntax for that is just nums, brackets, 3, and closing bracket. For example, here, nums of 3. Nums of 3 is going to be this element. So when I call nums of 3, I'm actually going to get the value of the fourth element in my array nums. And because of the things that we have just learned, you can't do something like nums of 10 or nums of minus 1. These kinds of things are called getting out of the array's bounds. For example, nums of 10 is actually this memory chunk, which does not belong to the array. And so is nums of minus 1. This is also a memory chunk that does not belong to the array. So whenever you get out of the array's bounds, the computer is not going to allow that, and you will definitely have a runtime error. Then, the second operation we can do on an array is, of course, modify some element. For example, here, nums of 3 equals 10. So whatever was the value of nums of 3, now I'm gonna overwrite it, and the new value is going to be 10. Also here, you can't do something like nums of 10 equals 1, because this element doesn't exist. Also will result in a runtime error. And the third thing that you can do is not actually an operation, but we are going to do this most of the times when dealing with arrays, is to actually traverse the array. There are multiple ways of doing this, but the most common one is this type of for loop. Obviously, this is pseudocode, might not be the same in all the languages, but doesn't matter. For num in nums, print num. For example, here, I traverse each and every element of the array nums, and I just print its value. Or you can traverse the array by its indices. Now, the array nums, because it has a size of 10, all the indices are going to be between 0 and 9. So I can have an index I to go through all the values from 0 to 9, and then I'm going to print nums of I. Okay? So see the difference? Here we access the value of each element by the index, nums of I. Here, this variable num actually will take the value of the element that we are iterating on. Of course, traversing an array in this manner by the indices is a little bit more flexible, because you can do things like, you know what, I want to traverse only the elements of the array nums which have indices multiple of 3, right? So I want to do something like this. I want to print nums of 0, then I want to print nums of 3, nums of 6, and nums of 9. Obviously, we can do this with a for loop, in which we go again with I from 0 to 9, but we make sure that we increase I with 3 every time. This can be done, and in this way you can't do that because, of course, you're limited to going through each and every element. And also worth mentioning is that you can do this type of traversal only on arrays because you can randomly access every element you want super quick in constant time. We are going to see that there are some data structures, for example, linked lists, in which you can't do that. You are restricted to traverse each and every element if you want to find a specific one, right? Or at least each element until you get to the specific one. But here we can randomly access whatever element we like. We can do nums of 3, nums of 8, nums of 1, nums of 5 in this order randomly, and all of these accesses are going to be constant time. So the last thing that I want to do here is, of course, write the time complexities of the two operations, access and modify. Both of them are constant. Awesome. And of course, traversing an array depends on how many elements you actually want to traverse. Most of the time, we are going to traverse all the elements in an array. So if, let's say, the array has a size of n, traversal is going to be big O of n. And this is all you need to know about the static arrays, guys. Now, to summarize the lesson, I want you to remember the following things. In static arrays, you can have elements of only one data type. In static arrays, you always need to know what's going to be the size of that array because it's going to stay like that and you can't change it anymore. You can't have more elements. Obviously, you can have less elements. If from these 10 elements you are just going to use 4, you are allowed to do that, but you are going to waste memory, right? So why would you even do that? Then I want you to remember that whenever we declare an array, behind the scenes, the computer finds a contiguous zone of memory, and that memory is going to be reserved only for the array. So this is why we can never exceed the array's bounds. That is not memory that belongs to the array, and we are going to have a runtime error each time we do that. Then I want you to remember that we can randomly access every element in constant time. We can modify every element in constant time. And last but not least is that we can traverse the array either like this, traversing each and every element, or by the indices, which is the more flexible option if we want to maybe skip some elements from the array. And this is it, guys. I'll see you on the next lesson where we are going to find out about dynamic arrays. Bye.